So we've done integration by parts, and what we're going to do today is rapid repeated integration by parts. We did some examples, and you had some in your homework where you did integration by parts several times. Well, this process allows you to do that in a little bit more streamlined fashion. So the process is you're going to choose your parts u and dv, just like you have been with log poet, so logarithms, then polynomials, then exponentials, and last trig. You're going to differentiate your u's and you're going to integrate your dv's. You'll multiply down the diagonal, and you'll see what this all means in a minute, and then integrate once along the bottom, and you're going to use alternating signs. Alright, so here's our process. We've got a polynomial and a trig function. So I'm going to let u, we're going to do this a little bit different. U is going to be x cubed. My dv is going to be sine 2x. So I'm going to differentiate this side, and we know the polynomial will eventually go to 0, so we're going to stop there. So we're going to have 3x squared, 6x, 6, and 0. I'm going to integrate this side that many times. So the integral of sine is going to be a negative, this will be negative 1/2 cosine 2x. Integral of that's going to be a negative 1/4 sine 2x. Then we're going to have a positive 1/8 cosine 2x, which makes our last one a negative, or a positive 1/16 sine 2x. Alright, then we're going to draw some diagonal lines. So you're going to start, because remember the integration by parts is u v minus v u. So right here, this is my u, that's v, this is v du, but we're going to keep going till we get to the bottom. Then we go once across the bottom, and we're going to use alternating signs because it's uv minus v du, so it's going to alternate between plus, minus, plus, minus, plus. So you multiply all the way down to the bottom, and then we'll integrate. So this is going to equal, multiply here, so I'm going to have x cubed times negative 1/2 cosine 2x minus 3x squared times negative 1/4 sine 2x plus 6x times 1/8 cosine 2x minus 6 times 1/16 sine 2x. And then the last one, 0 times this is 0. So we integrate across the bottom, so it's going to be plus the integral of 0 dx. And then I'll just simplify a little bit here. So we're going to have a negative 1/2 x cubed cosine 2x, a minus minus, so we're going to have a plus 3/4 x squared sine 2x, plus plus, so 6/8 or 3/4 minus a 6/16 sine 2x, or you can make that 3/8, plus the integral of 0 is just going to be c. Alright, x to the 5th times e to the negative x. So my u is going to be x to the 5th. My dv is going to be e to the negative x. So I'm going to go ahead and do the polynomial all the way to 0. So 5x to the 4th, 20x cubed, 120x squared, 240x I was jumping ahead. 3 times 20 is 60. 60 times 2 is 120. And then we have 120 and 0. My e to the x is just going to keep alternating. The next one's going to be negative e to the negative x. The next will be positive e to the negative x. Negative e to the negative x. Positive e to the negative x. Negative e to the negative x. And positive e to the negative x. Okay, then we're going to draw our diagonals. So we'll have a diagonal here, 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 to the last one, and then we go straight across the bottom. We're going to alternate our signs. So plus, minus, plus, minus, plus, minus, plus. And multiply. So we're going to have x to the 5th times negative e to the negative x. So that's going to be a negative x to the 5th e to the negative x. My next one, we've got a minus 5x to the 4th e to the x. Then we have 20 and a negative, so this will be minus 20x cubed e to the negative x. Next one is again a negative, 60x squared e to the negative x. 120 times the negative. Okay, then we have the 120 times the negative, but it's negative again. These are all going to end up being negative. Okay. And then we integrate across the bottom, which is just going to be plus c, because we're just integrating 0 again. This next one we have actually already done before, but now we're going to do it using rapid repeated integration. So my u is going to be e to the x. My dv is going to be sine of x. So I'm going to go derivative of e to the x is e to the x. Integral of sine is a negative cosine. Derivative is e to the x. Integral is negative sine of x. And I'm going to stop there, because what we're going to end up doing is we're going to have at the end the integral with the sine e to the x. So as soon as you have this again, then we can stop. So we'll draw our diagonals and our straight line across. Use alternating signs. So the integral of e to the sine e x to the sine times sine x equals, so u dv, so we're going to have a minus e to the x cosine x minus minus, so plus e to the x sine x minus the integral of, so the integral across the bottom, minus e to the x sine x dx. Okay, so we're going to apply the strategy of adding this over. So we have 2 times the integral of e to the x sine x dx equals negative e to the x cosine x plus e to the x sine x. Go ahead and put our plus c there, and then we'll just divide by 2. Plus c. This one we're going to take a similar approach, but the constants are going to make this a little bit more involved, but the repeated integration by parts makes this a lot easier. So my u is still going to be e to the 7x. My dv is going to be cosine 5x. So my derivative is going to be 7e to the 7x. My integral is going to be 1/5 sine 5x. Derivative will be 49e to the 7x. My integral here will be -1 over 25 cosine 5x. Okay, and then we put this all together. But again, this is one where we're going to be adding over the integral. So we're going to have the integral of e to the 7x cosine 5x is equal to, we've got 1/5 e to the 7x times sine 5x. A minus minus, so this next one's going to be plus. I'm going to go ahead and combine. I got 7 and 125, or 7, yeah. E to the 7x cosine 5x. And then across the bottom, we have a minus. I'm going to leave these on the outside, so 49 over 25 times the integral of e to the 7x 5x cosine 5x dx. Okay, so I'm going to take this and add this over. So I'm adding 49/25. So that's going to be 49/25 plus 25/25, which gives me 74/25 of the integral e to the 7x cosine 5x. Just copying everything straight down. So we're going to multiply by the reciprocal of this. So my final answer, the integral of e to the 7x cosine 5x is equal to 25/74 of all this. And you could distribute that through and simplify if you want, but you do not need to. This next one here, it's not cosine 5x, it's just cosine 5. So this is just a constant. So this is just going to be 1/7 e to the 7x times the cosine of 5 plus c. Okay, and these last two, we're going to use something called reassociating the factors. Okay, and you'll see what we mean by that. But we're going to be moving stuff around because all we're doing here is multiplying when we go through this process. So here I'm going to let my u equal x to the 5th. dv is going to be e to the x cubed. Okay, so if I take there's an issue here. So this is how you'd probably want to start it out. But if I take this one's derivative, or take this one's integral, we have to include the chain rule. So let's think about what this integral needs to be. Okay, we know from experience, hopefully at this point, that if I integrated something like this, I'd need to have this one's derivative needs to be a part of the integral. So let's say I do this integral, which means I'm going to do a u substitution, where u would be x cubed, du would be 3x squared. So then this integral would be 1/3 the integral of e to the u du, which would be 1/3 e to the u plus c, which would be 1/3 the integral of x cubed. So in my dv, rather than having e to the x cubed, I'm going to have x squared e to the x cubed. So this is not how I'm going to start this problem. This side I'm going to have x squared e to the x cubed. So instead of x to the 5th here, I have x cubed. So I take this one's derivative, which gives me 3x squared. This one's integral we just worked out to be 1/3 e to the x cubed. Okay, which is kind of what we started with again. So what we're going to do is called reassociate the factors. I'm going to make a break in here because I'm going to change what this looks like. I'm going to take this x squared and give it over here, because if we were doing uv times minus v du, you'd multiply down the diagonal and across. So when I multiply, I can put that with this one. So this is going to be 3, and I'm moving the x squared over here. So this is going to be 1/3 x squared e to the x cubed. So this is this same integral just times 1/3. So our result will be the same, just times 1/3. So our derivative here is going to be 0. My integral here is going to be 1/9 e to the x cubed. All right, so what did we end up with here? We skip this one. This break doesn't really exist. Okay, so we're going to have this times this. So 1/3 x cubed e to the x cubed minus 3/9, which would be 1/3 e to the x cubed minus, or plus the integral across the bottom, which is 0. So we have plus c. Okay, we're going to do something similar here. Okay, we know from our rules, log poets, that our u should be the natural log of x squared part. My dv then is going to be x cubed. Okay, so we're going to take this derivative. So this is going to be 2 times the natural log of x times the derivative of natural log of x, which is 1/x. On this side, I'm going to have 1/4 x to the 4th. Okay. If we were integrating this, we'd be multiplying this times this, which means the 1/x is going to play with this one. So we're going to go ahead and just deal with that now. So on this side, I'm going to have 2 natural log of x. Over here, I'm going to have 1/4 x cubed instead. Okay, we'll take this one's derivative. So 2 times 1/x. The integral here, we're going to have to add 1 to the exponent, which will be 4, and divide by that. So 1/16 x to the 4. Now at this point you have options. You could reassociate the factors and do this again, or we can just do it in the integral. So that's how I'm going to choose to do it, but you could do this whole process again if you wanted to. So my integral now, let's do our diagonals. We've got this diagonal, skip to this diagonal, and across. So we're multiplying here. So this is going to be 1/4 times x to the 4th times the natural log of x squared. Skip skip over this one, we have this one. So we have a minus 2/16 natural log of x, x to the fourth, plus across the bottom, we've got 2 times 1/16. So I'm going to say 1/8 times the integral of 1 over x times x to the fourth. So that's going to be the integral of x cubed. Make that a 1/8. This is going to be 1/4 x to the fourth, so we're going to have 1 over 32 x to the fourth plus c. So again, we could have done that in another step here. We'd end up with the same result. So this is rapid repeated integration by parts.